Right, we're going to look at quadratic equations, but it's going to be for the grade 9 level kind of equation. There are more advanced quadratic equations in terms of the type of expression you get, but those will be in grade 11 and grade 10. Now, remember the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0, but obviously we're going to explore all sorts of scenarios that may come up. Okay. Right, first, quickly, what are quadratic equations? Well, remember when you did equations in grade 8 and 9, in grade 8, you talked about linear expressions, and linear expressions brought about linear equations because the highest degree in the expression is x to the power 1. So those are linear expressions, and when they're in equations, linear equations. Even in grade 9, you then get to do graphs, and they are called linear graphs. So it's about the expression that is used. Now the same thing in quadratic equations is happening. There's a quadratic expression that leads to a quadratic equation. A quadratic expression is simply any expression in your algebra where the highest degree is squared or is 2. And it doesn't matter how many terms there are, because there's a tendency sometimes when it gets to quadratic equations, people are only thinking about those equations with 3 terms, and yet the expression can have 1 term, can have 2 terms, can have 3 terms, and in this case, as long as the highest degree is squared. And from those quadratic expressions, we get quadratic equations. And this is exactly what we're going to be dealing with. And these are some of the examples that I'm referring to of quadratic equations. Can get one with 2 terms, 3 terms. You will learn in grade 10 about quadratic functions, which is a parabola graph. And that graph, again, is because it will have a quadratic expression in it. So you want to get used to that. And maybe just a glimpse, when you're doing calculus in grade 12, you're looking at cubic expressions, and those cubic expressions give cubic equations, and in 10 there are cubic graphs that will come out of that. So get used to the naming of things in mathematics based on expressions, and this is what quadratic equations are all about. It's about those expressions that are quadratic expressions that now we'll find in equations. Okay. Okay, let's look at a couple of examples. Let's solve the following equations. Here's a quadratic equation. And I will come back just now after a few examples on the real concept around how quadratic equations are solved. But then once you understand that, you never have a problem with any quadratic equation. Here, it's already in the standard form. We need to factorize the left-hand side because a common factor situation, and each factor would need to be solved. We want to know what makes x equals to 0. We want to know what makes x minus 3 is equal to 0, and x will be equal to 0, or x is equal to 3. Now, x is equal to 3 simply because you can take that expression inside the brackets and say what makes x minus 3 equals to 0. And then you solve that simple equation, and then out comes your solution. But this is rather a long approach and not a necessary step if you've got a very basic straightforward equation. I will talk about what needs to happen and how do we skip those unnecessary steps. Look at number 2, in fact. Number 2 is just factorize, ready for solving. In fact, a question like that will only be 2 marks because all you need to do is figure out what makes each bracket of these factors equal to 0. And therefore, if you equate each one of those expressions and solve it, you'll get your x is equal to 2 or x is equal to -5. But again, this step over here is an unnecessary step, but I'm still explaining basic things so that you understand where things are coming from. Now, number 3 is needing factorization because it's already in the standard form. It's a difference of 2 squares, so x minus 4 into x plus 4. And again, what would make each bracket equal to 0? If x is equal to 4 in the first, or if x is equal to -4 in the second bracket. Now this is important, but now let's talk about that method. Why are we doing what we're doing? Why are we making sure that we factorize sometimes and there's no factorization needed sometimes? Now, the method in solving quadratic equation is this. You first need to make sure that you understand the step or level your equation is in. Is it an equation that needs to be put in the standard form first? Is it an equation that needs to be factorized? Is it an equation that has already been factorized but needs to be solved? That is crucial because then it helps you to immediately get to the next step of your equation. So make sure first, if it needs be, that your equation is in the standard form equated to 0. That simply means gather all your terms on the same side equal to 0. And then the expression that you get on the left-hand side would need to be factorized. So it must be in its factor form, still equated to 0. After you've done that, you then need to look at each individual factor. It doesn't matter what factorization came out of your factors, but the most important thing is look at it in your factor and analyze what each factor would be in terms of giving us 0. Now, why is that? That's because there's a very important aspect of solving your quadratic equations where if we want to make the left-hand side equal to the right-hand side, now remember the right-hand side is already equal to 0 since you put the equation in the standard form. It would mean that knowing our multiplication and properties of 0, it would mean that if any one of the factors is equal to 0, we would get the left-hand side to be 0. And that's exactly what you're doing. You're trying to figure out for each of the factors what would make that bracket equal to 0 if x is equal to 2. What would make that bracket equal to 0 if x is negative 5? So basically you are already dealing with each individual factor, and that's what it means solving each factor, because you want to know what would make that factor equal to 0. Now some of the questions would be straightforward because you can see with your simple arithmetic what the value of x must be, but other questions might need to do that method of equating each factor to 0 and then solving that small equation that comes out of that. Now you then need to be able to identify your equations as they come. For instance, I've taken one equation here and I've written in different forms. If I look at A is already in the standard form, so it's not needing me to put it in the standard form, but it's already in the standard form. That means I need to factorize and equate it to 0. So I need to factorize, then solve each factor. But look at B. B is not in the standard form, so I would need first to get it to be in the standard form. That means gathering all terms on the same side and factorize that expression, then solve. And C, same thing, it's not in the standard form. I would need to multiply out the brackets. Be careful, this is not 0. So a lot of people tend to make an error when it's like this. They think that you can go x is equal to 10 or x plus 3 is equal to 10. You can't do that. Okay? You need to multiply this out, get it to be in the standard form, then factorize. So it's very, very important that you take note when an equation is given. In what step or level is it in? Is it ready for you for the next step? And if not, you need then to work on it until you get it to be ready. And the most crucial part is standard form, factorize the expression on the left-hand side, equate it to 0, and then solve each factor by trying to figure out what would make each factor equal to 0. Look at number D. Number D, again, is not ready for our solving. It's not even in the standard form. So first you'll have to put it in the standard form. Once you're done, factorize that expression, and then solve the equation by dealing with each individual factor in your factorization. So very, very important to actually understand where your equation is at. But look at number E. Number E, and this happens quite a lot where learners think, ooh, I'm seeing brackets, let me multiply. No, you're solving a quadratic equation, but it's already in its factorized form, equated to 0. Great. The next step is a solution where x is equal to 2, x is equal to negative 5, and you're done. And that's what we're doing in example 2 over here, where it was already in its factorized form equated to 0. So you have to be really observant when you're dealing with quadratic equations. Where am I at? Do I need to set up a standard form? Do I need to factorize? You need to look very carefully. And this one is quite a common error because learners are so used to multiplying brackets, they just multiply. And yet there's no need. Because if you multiply, you get again a quadratic equation in the standard form. Then what do you do next? You factorize and you go back to that step that you were given. So that would be a waste of time. If it's ready for solving, solve. And that would have been a 2-mark question in a test. Let's have a look at more examples just to apply different scenarios that might come up in your quadratic equations. The first one, you want to watch out for this. You never ever divide in a quadratic equation by a variable. Otherwise, you lose one of the solutions. For instance, if you divide here by 5x, you will end up with x minus 5 equals to 0. And what happens? That's a linear equation, and you'll get only one solution. So we never divide by a variable, but we can always divide by a constant term. And that's what we're going to do here, because we're noticing that our terms have got a constant factor of 5. So we're going to divide everything by 5, end up with that. Now we get to that stage where we factorize. Remember the method. The equation was already in the standard form. We're just fixing our common factor. Now we got to the stage where we need to factorize and take out x as a common factor, and that enables us to get the two solutions that are supposed to be there. Now, why are we putting O in our answers in equations? Well, in quadratic equations, remember, the question was asking us to find the value of x that will make the left-hand side equal to the right-hand side. If we plug in the equation x is equal to 0, the left-hand side will be equal to 0. So that solves the equation. Or if we plug in x is equal to 5, it will still solve that equation. We still get left-hand side being 0. So either this solution or that solution would be the solution to the equation. And that's why we're using or, because we don't need both, we just need one of them and it still works. Let's look at another example. This one I brought up because not every equation that has already been factorized equated to 0 for you is easy to see by inspection what the solution would be. So what you would always do is take each factor equated to 0, because you want to know what would make this factor equal to 0, or what would make that factor equal to 0. And that sets up a nice easy equation which you solve, and in this case your x is equal to 5 over 2, or your x is equal to a third. Very easy. In the other one, again, be careful. Very common mistake where people think, I can just go x is equal to 12. There's no such thing. The equation is not in the standard form. So first, standard form, let's go. And that standard form, you have to multiply out and obviously transpose the 12 and you get negative 12. Now you're ready to factorize and solve each factor. X is equal to 6 or x is equal to negative 2. Easy. Next one, there are two methods here. But I'm going to first explain the one that I'm a big fan of for various reasons, which I'll explain. And here, it's not in the standard form. I would multiply out, and then when I multiply out the left-hand side, I get x squared minus 8x plus 16. Then I would write my equation in the standard form, and I get x squared minus 8x plus 7 equals to 0. Now I'm ready to factorize. And there's my factorization, perfect. And then I can now solve each factor and get my solutions, x is equal to 7 or x is equal to 1. Here is the method that I'm not a fan of because of a common error that always comes up. Your equation has got perfect squares on both sides. It is one term equals to one term, which is good because then we can find the square roots of both sides. My worry is here, a lot of people think that the only square root they need to consider is the positive square root. So they end up with x minus 4 is equal to 3. Well, the square root of the left-hand side is x minus 4. The square root of 9 is 3. Negative 3. So that would then create two scenarios where we need to consider the positive square root and the negative square root. And they will still give us the correct answers of x is equal to 1 or x is equal to 7. So you just want to be on the lookout for this because it's a common error. And I would really not advise anybody who forgets easily to actually use this method, even though it's quick and easy, but then you're going to have to be sharp and always remember that there's two possible square roots. But here you are safe because your quadratic equation comes out as you factorize, the two possible solutions will pop up on their own. Here's another one, and here I wanted to emphasize that when you're solving your quadratic equations, one of the most important things, make sure that you've got a positive x squared. So our first step is to fix that by multiplying everything with a negative, and then we're ready to factorize, and then we can solve our equation. X is equal to 7 or x is equal to 3. Here's another one where now, if you notice, after getting your equation to be in the standard form, now there's a common factor of 2 in all your terms. Hey, don't waste your time adding unnecessary steps, taking out the 2 that is a common factor, then dividing. No. Just divide now everything by 2 without even showing us, and write out what is left after dividing by 2, and we've got a nice easy equation, factorize, and then solve. Now, quadratic equations are pretty easy to solve, but your skill on factorization is crucial. You might think that you're struggling with quadratic equations, but actually you're struggling with factorization. So fix that part of the problem so that you can do well in your quadratic equations. Okay.